What lies at the very edge of our solar system? It's a question that feels almost impossible to answer. For centuries, we imagined our sun as a solitary lantern burning in a cold, endless night. But in truth, the sun is more than a source of light. It is an architect, inflating a vast bubble around us, a shield against the galaxy beyond. And somewhere at the ragged frontier of that bubble, Voyager made a discovery so strange, so unexpected, that scientists had to borrow the language of poetry to describe it. They called it a wall of fire. But what does that mean? There is no flame in space, no oxygen, no roaring blaze, and yet Voyager's instruments whispered of temperatures tens of thousands of degrees higher than what we'd ever imagined. Beyond Pluto, beyond the Kuiper Belt, beyond even the quiet drift of the outermost comets, Voyager had found something extraordinary: the sun's final breath, colliding with the raw wind of the galaxy. Imagine it, a spacecraft the size of a small piano, crawling farther from Earth than anything we've ever made, crossing into a zone where our star's influence shatters, and the Milky Way itself presses in. This is not just a scientific milestone, it is a turning point in human history. For the first time, we have stepped outside the cradle of the sun and felt the touch of interstellar space. So what really is this wall of fire? Why does it matter? And what does it mean for the future of our species, the dreamers, the explorers, the ones who will follow Voyager into the great unknown? This is the story of the solar system's frontier, the edge of everything we thought we knew. What lies at the very edge of our solar system? That question is not a scientific one alone, it is a human one. Because when we look outward, we are really asking something deeper. Where do we end, and where does everything else begin? We have always lived inside the sun's light. Every second of every day, our world is bathed in its energy, sculpted by its warmth, cradled by its magnetism. To us, the sun is ordinary, predictable, a background presence. But to Voyager, the tiny spacecraft we launched almost half a century ago, the sun is not just a star. It is a presence that can be measured, mapped, and finally escaped. And so, when Voyager crossed that invisible line, the place where the sun's influence gives way to the galaxies, the instruments did not just record data. They carried us across a threshold no human had ever known existed. They found what some would call a wall of fire. But to understand why this discovery was so astonishing, we must begin not at the edge, but at the launch. Because the story of Voyager is not about machines, it is about journeys, both theirs and ours. It was 1977. The world was still in the afterglow of Apollo, still tasting the thrill of footprints on the moon. But the solar system was largely unknown territory. No one had seen Jupiter's great red spot up close. No one had traced the pale ribbons of Saturn's rings in detail. Uranus and Neptune were specks in telescopes, fuzzy dots, more mystery than planet. We were ambitious. We wanted to see them all. And the mathematics of the cosmos gave us a gift. In the late 1970s, the outer planets would align in such a way that a single spacecraft using gravitational slingshots could hop from one to another in a grand tour. If we missed that window, the alignment would not return for 176 years. Humanity had one chance. And so 2 spacecraft were built. They were not beautiful by the standards of Hollywood. No sleek wings, no gleaming chrome. They were functional, boxy, instruments bristling like quills, a golden record bolted to their side. Their names were simple: Voyager 1 and Voyager 2. They were machines of science, but also of story. For engraved on their discs were sounds of Earth, greetings in dozens of languages, music from Beethoven to Chuck Berry, the laughter of children, the heartbeat of a mother. They carried not just instruments, but identity. At launch, no one imagined these spacecraft would one day leave the solar system. Their task was humbler: visit the planets, send back images, then fade into silence. And yet something about Voyager was different. It was not just a probe, it was a time capsule. Engineers, perhaps without fully realizing, had given it enough durability, enough redundancy to outlive its initial purpose. By 1979, Voyager 1 had swept past Jupiter. The images it returned were a revelation. The red spot was not a blur, it was a storm larger than Earth, swirling with furious complexity. The moons, once thought barren, were alive with volcanic eruptions and ice fields. When Voyager turned its camera, we saw lightning in the clouds of Jupiter. We saw shadows stretching across rings and surfaces. The solar system was no longer distant, it was real. 2 years later, Saturn. Voyager revealed rings that were not uniform bands but sculpted structures, braids, spokes, waves, as if invisible hands were plucking at cosmic strings. Titan, Saturn's largest moon, showed a thick orange atmosphere, perhaps, scientists whispered, hiding seas of methane. Voyager 2 carried on. It alone would fly past Uranus and Neptune, the first and only time humanity has ever visited those worlds. There it saw tilted magnetic fields, boiling storms, dark blue gales faster than any wind on Earth. These were not dead rocks, they were restless worlds. By the late 1980s, Voyager had fulfilled its promise. It had completed the grand tour. Any other mission would have ended there with applause, papers, and retirement. But Voyager did not stop. It kept moving, away from the sun, away from the planets, into a realm no human eye had ever seen. The outer solar system is not a place of spectacle. There are no glowing storms, no painted rings. It is emptiness. The sun shrinks to a star among stars. Day becomes indistinguishable from night. Silence deepens. And yet, Voyager continued, powered by a small nuclear heart, its instruments still whispering across the gulf. Bit by bit, photon by photon, its signals reached Earth, delayed by hours of light travel time, weaker than the flicker of a candle seen from across an ocean. Scientists began to wonder, could Voyager, against all odds, reach the edge of the sun's realm? You see, the sun is not simply light. It breathes. From its surface streams the solar wind, a constant gale of charged particles rushing outward in every direction. This wind inflates a colossal bubble around us called the heliosphere. Inside it, every planet orbits, every comet drifts, every spacecraft sails. Beyond it, the galaxy waits, with its own radiation, its own storms, its own winds. And somewhere, far beyond Pluto, the sun's wind collides with the interstellar medium, a frontier, a border, a skin of the bubble. This was where Voyager was headed. Slowly, inevitably, it drifted toward the limit of the familiar. Imagine this boundary. There is no wall you can touch, no flashing beacon, no sudden cliff. Instead, it is a region where invisible forces shift. The solar wind slows, then falters. Galactic particles press inward. Magnetic fields twist into new alignments. For decades, this frontier was theory. Equations scribbled on chalkboards, simulations running on early computers. No one had crossed it. No one knew what it would feel like. Would the spacecraft die before it reached it? Would its signals be too faint, its power too weak? These questions lingered as Voyager crept outward, mile after mile, year after year. What makes Voyager's story powerful is not just the science, it is the patience. Generations have passed since its launch. The engineers who tightened its bolts, the scientists who programmed its first commands, many are gone. Yet their machine endures. Like a message in a bottle, Voyager has outlasted those who cast it into the sea. And now it was approaching the unseen horizon. But how do you know when you've reached the edge of the sun's influence? There is no signpost in the void, no line painted across the sky. You must measure the invisible, plasma density, particle flux, magnetic orientation. You must feel through instruments what no human sense can detect. Voyager would do just that. As the 2000s turned into the 2010s, Voyager was more than 100 astronomical units from Earth, 100 times the distance from Earth to the Sun. Out here, light takes over 16 hours to arrive. Out here, the sun is a pale ember, not a blazing furnace. And then, in 2012, the first spacecraft, Voyager 1, recorded something extraordinary. Charged particles that once flowed freely from the sun vanished, replaced by a flood of galactic cosmic rays. Magnetic fields shifted direction. Plasma density, measured indirectly, spiked to levels no one had expected. Voyager had crossed the heliopause, the true edge of the sun's bubble. But in crossing, it found something stranger still, a region where plasma burned tens of thousands of degrees hotter than inside, a place that, in the language of metaphor, became known as a wall of fire. But what exactly was this wall? Why would empty space, thinner than any vacuum on Earth, blaze with such phantom heat? And why did this discovery force us to rethink not only the solar system's edge, but the sun's relationship with the galaxy itself? These questions carry us forward, because to grasp the meaning of the wall of fire, we must first understand the heliosphere, the great solar bubble that contains our world. And that is where our story drifts next. When Voyager first reported the strange plasma beyond the heliopause, the question was immediate: how could such a frontier even exist? The answer lay not in the galaxy beyond, but in the sun itself. Because our star is not a silent lamp, it breathes, it builds, it sculpts. Every second, from its roiling surface, charged particles stream outward at hundreds of kilometers per second. We call this the solar wind, an invisible hurricane of plasma carrying the sun's magnetic field into space. And though each particle is tiny, together they are relentless. Over billions of years, this constant outflow has carved a structure around us, a vast teardrop-shaped bubble known as the heliosphere. Inside this bubble, the sun reigns. Its wind dominates, its radiation sets the rhythm, its magnetic field shapes the invisible scaffolding of space. Outside it, the galaxy rules. The heliosphere, then, is not merely a region, it is a shield. To understand the heliosphere is to understand why Earth even has a chance at life. Beyond its walls, the galaxy is violent. Supernovae scatter radioactive shrapnel. Distant quasars hurl radiation like artillery. Cosmic rays, accelerated to near light speed, tear through anything in their path. But inside the heliosphere, much of that fury is held back. Not perfectly, cosmic rays still slip through, but enough that planets can hold atmospheres, water can remain liquid, and fragile molecules can assist. Without this shield, DNA would be shredded, electronics fried, atmospheres stripped bare. The heliosphere is our invisible fortress, and Voyager was drifting toward its battlements. But what does this fortress look like? For centuries we could only guess. Was it spherical, like a balloon, or was it a comet shape, with a long tail stretching downwind, sculpted by the flow of the interstellar medium? The truth is more complex. Imagine the sun as a ship ploughing through a cosmic ocean. The solar wind inflates the bubble, but the galaxy pushes back. Ahead, the heliosphere compresses into a blunt nose. Behind, it stretches into a tail that may extend for hundreds of astronomical units. And within, magnetic fields twist like invisible ropes, binding the solar wind into spirals. This is not a static structure, it breathes. With every solar cycle, as the sun waxes and wanes in activity, the bubble expands and contracts like a living lung, and it is riddled with turbulence, shocks, and layers. For Voyager, crossing the heliosphere was like peeling an onion of invisible skins. First came the termination shock, the place where the solar wind, racing outward supersonically, suddenly slowed as it crashed into the pressure of interstellar space. Here, particles piled up, heating to millions of degrees, though still too sparse to warm anything solid. Voyager felt the jolt, a cosmic speed bump on the road outward. Beyond lay the Helios Heath, a turbulent zone where slowed solar wind churned and eddied. Here, fields tangled, particles ricocheted, and the very fabric of plasma became chaotic. Voyager drifted through this twilight sea for years, carried by forces invisible but immense. And then, at last, the heliopause, the thin final membrane. Inside it, the sun's particles dominated. Beyond it, the galaxy took over. This was the crossing point, the edge of the bubble, and it was here that the plasma burned hotter than anyone expected. When scientists first examined Voyager's data from beyond the heliopause, disbelief flickered. Plasma temperatures of tens of thousands of Kelvin, how could that be? In a near vacuum, where particles were so few and far between, what did hot even mean? The answer lies in motion. Temperature at its core is not about sensation, it is about velocity, the speed at which particles move. In this region, though matter is sparse, the few particles that exist zip around with immense energy. They are fast, restless, charged by the collision of the sun's wind and the galaxy's pressure. This is why the metaphor wall of fire clung to the discovery, not because flames flickered in the darkness, but because the particles themselves carried the heat of invisible collisions. But the heliosphere is more than a curiosity of physics. It is a signpost of belonging. It tells us where we end and where the galaxy begins. Consider what this means. For the first time, humanity has mapped the borders of the sun's kingdom. Every planet, every moon, every comet, all orbit within this invisible bubble. But Voyager showed us that this bubble is finite. The sun does not rule endlessly. Its breath, though vast, eventually fades. Beyond that line, we are tenants in the galaxy, no longer under the shelter of our parent star. This raises haunting questions. If the heliosphere shields us, what happens when we leave it? What happens to astronauts or future starships once they drift beyond this protection? The galaxy is harsh, Beyond the bubble, cosmic rays surge with full fury. Any human vessel must carry its own shield or risk being stripped by radiation. In this sense, the heliosphere is not just an island, it is a cradle. And like any cradle, we cannot stay in it forever. But leaving it will demand a new kind of resilience. What makes the heliosphere even stranger is its variability. The sun's activity rises and falls in cycles of about 11 years. When storms erupt on its surface, when sunspots flare, the solar wind strengthens, the bubble swells. When the sun quiets, the bubble shrinks. This means the heliosphere is not a fixed wall, but a breathing skin. The distance of the heliopause is not the same for Voyager 1 as for Voyager 2. In fact, Voyager 2, which crossed in 2018, measured the boundary at a different distance than Voyager 1 had in 2012. The bubble shifted, reshaped by the sun's rhythm. This dynamism is humbling. We like to think of the solar system as stable, eternal, but in truth it is alive, its frontier pulsing in time with the star that feeds it. Why does this matter? Because the heliosphere is not merely a bubble, it is armor. It deflects much of the galaxy's cosmic radiation, protecting us in ways we barely appreciate. Without it, Earth's atmosphere might have eroded long ago. Without it, life's fragile chemistry might never have had the space to thrive. And so when Voyager crossed the heliopause, it was not just marking a line in space, it was stepping out of a sanctuary into the raw exposure of the wider galaxy. Imagine walking out of a walled city into an open wilderness. Inside, you are shielded from storms, predators, chaos. Outside, you are vulnerable. That is the difference between the heliosphere and interstellar space. And yet Voyager survived. Its instruments, though limited, continued to measure. Its signal continued to whisper back. Out there in the thin fire of the heliopause, the spacecraft kept going. This resilience is a lesson. The heliosphere may protect, but it is not absolute. Beyond its walls there is danger, but also freedom. If Voyager can cross, so can we. One day perhaps human starships will follow the same road. They will leave the sun's shield and sail into the galaxy beyond. But to do that, we must understand every layer of the heliosphere, because only by grasping its structure can we prepare for what lies outside. The first layer Voyager encountered on its path outward was the termination shock, the invisible barrier where the solar wind slowed abruptly, as if slamming into the pressure of the galaxy. It was the opening step into the heliosphere's twilight. And so, to truly follow Voyager's trail, we must descend into this region. What is the termination shock? What forces shape it? And why did crossing it reveal the sun's hidden violence at its very edge? It begins with a sudden slowing. For billions of kilometers, the solar wind races outward unchallenged, supersonic in its speed, scattering through space like an endless exhale. But nothing moves freely forever. Every current meets resistance, every river meets a shore. And for the sun's breath, that shore lies at the termination shock, a vast invisible boundary where the solar wind collides with the thin but unyielding pressure of the galaxy. Here, in the deep frontier of the solar system, the solar wind falters, its speed plunges, its energy transforms. It is as if the sun's breath, after rushing outward for 100 astronomical units, suddenly hits a wall of silence and slows to a crawl. Voyager was the first to cross this frontier. In December of 2004, Voyager 1 recorded something strange. Its instruments, long accustomed to the steady gale of solar particles, detected a change. The wind had slowed, and the flow of charged particles had shifted. For the first time, the spacecraft had crossed the termination shock at roughly 94 AU from the Sun, over 14 billion kilometers away. It was not a sharp line, like the edge of a cliff. It was more like turbulence in a river, a gradual but undeniable transformation. Particles once streaming supersonically now churned subsonically, bouncing, colliding, heating. The spacecraft had moved from a region of ordered flow to one of chaotic turbulence. For scientists, this was the first confirmation that the sun's influence was not infinite. It could be resisted. The interstellar medium pushed back, and the result was this invisible shockwave. The name may conjure violence, but the termination shock is silent, invisible, intangible. It is not fire or thunder. It is a shift in speed, a rearrangement of energy. When a flow of plasma traveling faster than the local speed of sound encounters resistance, it cannot simply decelerate gently. It crashes into a shockwave. On Earth, this happens when a supersonic jet breaks the sound barrier. In space, it happens when the solar wind slams into the interstellar frontier. At the termination shock, the wind slows from supersonic to subsonic, losing its ordered rush. Energy converts into heat, raising the temperature of the plasma. Magnetic fields twist, particle densities increase, turbulence reigns, the sun's breath becomes ragged, chaotic. It is the first warning sign that the heliosphere is ending. What makes Voyager's crossing so extraordinary is not simply that it happened, but that it happened at all. Remember, these spacecraft were launched in the 1970s, their power supplied by decaying plutonium, their technology primitive by modern standards, and yet decades later, their instruments were still sensitive enough to record the subtle shifts in plasma and magnetic fields that marked the boundary. Voyager 1 in 2004 and Voyager 2 in 2007 each felt the jolt, and though they crossed at different distances because the heliosphere itself expands and contracts, the story was the same. The sun's breath had met its match. The data they sent home revealed something more profound than numbers. It revealed a living frontier, a boundary that shifted with the sun's moods and the galaxy's pressure. It showed that our solar system was not an isolated bubble, but a participant in a larger struggle, star versus galaxy, wind versus wind. At the termination shock, the solar wind's velocity drops dramatically, but velocity is not lost, it is transformed. Energy from motion becomes energy of heat. Plasma particles jostle and collide, raising temperatures to hundreds of thousands of degrees. But here's the paradox. Despite the heat, the density remains so low that no object would burn. You could float through this fiery turbulence without feeling warmth because there are so few particles to transfer heat. It is hot by definition, but cold by sensation, a place where words like temperature stretch their meaning to the edge. This is the poetry of frontier physics: fire that cannot burn, a shockwave without sound, a turbulence you can never see. You might ask, why does this boundary matter? Why should we care about an invisible shockwave trillions of kilometers away? Because the termination shock is not just a feature of the heliosphere, it is a universal principle. Every star that breathes, every stellar wind that flows, eventually meets resistance. Every star is wrapped in a bubble of influence, and every bubble ends. The termination shock is the marker of that ending. To study it here, with Voyager's help, is to study the universality of stars. It is to glimpse how the sun interacts with the galaxy, how boundaries form, how cosmic weather shapes entire systems. It also has practical consequences. The termination shock determines how much cosmic radiation can penetrate into the inner solar system. It shapes the environment astronauts may one day sail through. It influences the stability of Earth's protective cocoon. It is not distant trivia, it is the unseen architecture of survival. Beyond the termination shock lies the Helios Heath, a chaotic expanse where slowed solar wind swirls, compresses, and fights with interstellar pressure. For Voyager, this region was a storm of invisible turbulence. Instruments recorded sudden spikes in particle energy, abrupt shifts in magnetic direction, bursts of unexpected radiation. It is here, in this twilight zone, that the sun's breath loses coherence, becoming a ragged tide. It is a place of uncertainty, where theory alone cannot predict behavior. And Voyager's data showed us that the Helios sheath is far more violent, far more active than anyone had guessed. For years, the spacecraft drifted through this storm, inching closer to the final edge. Imagine the patience required. On Earth, scientists watched for faint signals, tiny fluctuations in data, often buried in noise. The distance was so immense that it took over 14 hours for a single transmission to arrive. Every number was a message from a machine at the very edge of everything we knew. There is something almost spiritual about this. The spacecraft did not know what it was crossing. It did not know it had entered a new region, but its instruments recorded faithfully, like scribes at the border of an empire, and we, back on Earth, pieced together the meaning. It is a reminder. Exploration is not always dramatic. Sometimes it is quiet. Sometimes it is a faint line on a graph, a subtle change in particles, a boundary crossed without fanfare, yet the meaning is immense. One of the most haunting lessons of the termination shock is that boundaries are rarely simple. It was not a clean edge, but a region, a gradual unraveling. Voyager did not flip a switch from inside to outside. It drifted through turbulence, confusion, ambiguity. And this perhaps is the truest reflection of nature. We long for sharp lines, but the universe gives us gradients. Even at the edge of the sun's dominion, the border was blurred, messy, alive. And so, having crossed the termination shock, Voyager drifted into the heliosheath. It was now inside the sun's twilight, where the last remnants of solar wind struggled against the galaxy's weight. For years it wandered there, battered by turbulence, searching for the final threshold. That threshold would come later, at the heliopause, the ultimate skin of the heliosphere, the true wall where the sun ended and the galaxy began. And beyond that, the strange, unexpected heat that became the wall of fire. But first, Voyager had to navigate the Helios Heath, the sun's stormy borderland, a sea of chaos that stretched farther than anyone had predicted. What then is this heliosheath? Why is it so turbulent, so vast, and so important for understanding the sun's reach? And what did Voyager find as it drifted through this shadowy frontier, caught between two winds, our stars and the galaxies? That is the story that awaits us next. The moment Voyager passed through the termination shock, the solar wind was no longer the calm, orderly current it had once been. It had become something else, slowed, tangled, chaotic. The spacecraft had entered the Helios Heath, a vast borderland of turbulence where the sun's influence sputters and wanes. If the termination shock was the first warning, the Helios Sheath was the long exhale. It is here that the solar wind, robbed of its speed, churns and collides with itself. It is here that pressure from the galaxy presses hardest, shaping the sun's bubble from the outside. And it is here that Voyager wandered for years, suspended in the twilight of our star's dominion. The Helios Sheath is not quiet. It is a storm of charged particles, ricocheting and colliding. Magnetic fields twist into knots, snapping and reconnecting like taut wires. Waves of energy roll through, crashing into each other, leaving behind turbulence that Voyager's instruments strew, glad to decipher. Scientists once imagined the heliosheath as a thin skin, just a few astronomical units wide. Voyager proved otherwise. It is vast, stretching for tens of AU like an entire ocean, separating the inner solar system from interstellar space. The spacecraft, crawling at 17 kilometers per second, took more than a decade to cross it. This was not a smooth journey. It was a drift through uncertainty, through regions that shifted in density and pressure like tides. One moment, Voyager's detectors recorded surges of particles. The next, silence. It was as though the sun's dying breath was flickering, sometimes strong, sometimes weak, never predictable. Why was the heliosheath so turbulent? The answer lies in the sun's cycles. Every 11 years, the sun's activity rises and falls. Sunspots bloom and fade, magnetic poles flip, solar storms erupt and then quiet. Each change sends ripples through the solar wind, altering its speed, density, and magnetism. By the time these ripples reach the outer frontier, they have stretched into massive waves that crash into the Helios Heath. Imagine a tide pool at the edge of an ocean, disturbed not just by nearby winds, but by storms half a world away. That is the Helios Sheath, a frontier shaped not just by local conditions, but by the sun's shifting moods, amplified across unimaginable distances. This meant that when Voyager crossed, the region was not static. It was alive, changing, breathing. The Helios Sheath was not just a layer, it was a living frontier. One of Voyager's most startling discoveries in the Helios Heath was the behavior of radiation. Inside the heliosphere, the solar wind shields us from much of the galaxy's cosmic rays, but in the Helios Sheath, this shield weakens. Here, Voyager recorded higher levels of radiation than anywhere inside the solar system. Galactic cosmic rays, high-energy particles born in supernovae and other violent events, began to seep in. They surged and fell unpredictably, as though the Helios Sheath were a gate that sometimes opened wide and sometimes slammed shut. For Earth, protected by both the heliosphere and its own magnetic field, these fluctuations were irrelevant. But for spacecraft, and for any future astronauts venturing this far, they were warnings. Beyond the Helios Sheath, the galaxy's full radiation would stream in unhindered. The Helios Sheath, then, was not just a transition zone, it was a foretaste of interstellar exposure. Another mystery Voyager uncovered was the pressure balance at the edge. For years, scientists believed the heliosheath would be crushed thin by the interstellar medium pressing inward. But the spacecraft revealed that the sun's wind was stronger than expected, holding the frontier farther out. The heliosheath became a puzzle. How much pressure comes from the sun, how much from the galaxy, and how do the two forces meet? The data showed a frontier in flux, sometimes yielding, sometimes resisting. This balance is not just academic. It tells us how our solar system interacts with the galaxy, how stars carve their places in the cosmic web. Every heliosheath is a negotiation between inside and outside, self and other. Voyager showed us that this negotiation is more complex and more dynamic than we ever imagined. For Voyager itself, the heliosheath was a storm of static. Its plasma detectors, designed decades earlier, sometimes failed to keep up. The spacecraft, brightest antenna, still whispering across the void, had to fight through bursts of interference from particle waves. Its instruments registered strange spikes, moments when particle density surged and magnetic fields twisted violently. To scientists, these spikes were like footprints in sand. Each one hinted at unseen events, shockwaves from ancient solar storms finally arriving after years of travel, or collisions between magnetic fields snapping like cosmic whips. The heliosheath was a library of the sun's history, a record of storms written in plasma. Voyager was reading it line by line, year after year. Voyager pressed on, past 100 AU, past 110, past 115. Still it remained in the heliosheath. Scientists had predicted the heliopause might lie closer, perhaps 100 or 110 AU, but the edge refused to appear. It was humbling. The heliosheath was thicker, more stubborn than theory had allowed. The sun's breath reached farther than we thought, even in its dying gasps. Voyager drifted through this twilight for more than a decade, a wanderer in a borderland that refused to yield. Every kilometer carried suspense. Would the spacecraft survive long enough to reach the final edge? Would its instruments still function when it crossed the heliopause? Or would it die in the storm, its signal fading into silence before the moment came? There is something profoundly human about the heliosheath. It is a liminal zone, a place between worlds, neither fully inside nor fully outside. Voyager's long drift through it mirrors our own condition. We too live at thresholds, between safety and exposure, between past and future. The heliosheath teaches us that boundaries are not clean. They are messy, turbulent, alive, and crossing them takes time, patience, and endurance. Voyager embodied this lesson, moving forward inch by inch, year by year, through a frontier that seemed endless. And then, after years of wandering, Voyager began to sense changes. Plasma density increased sharply. The magnetic field shifted. Cosmic rays surged. These were signs that the spacecraft was nearing the heliopause, the final skin of the heliosphere, the true border where the sun's influence ends and the galaxy begins. The heliosheath was nearly behind it. The twilight was ending. Ahead lay a new reality, interstellar space. What did it mean to cross the heliopause? What happens at that invisible line where the sun's wind fails completely and the galaxy takes over? And how did Voyager's data reveal the shocking discovery of a region so hot, so strange, that scientists called it a wall of fire? That is the moment we now approach. At last, after years of wandering through the chaos of the heliosheath, Voyager began to sense something different. The signs were subtle at first, shifts in particle counts, changes in magnetic direction, faint whispers in the plasma, but together they pointed to a single truth: the spacecraft was nearing the very edge of the sun's realm. This frontier has a name: the heliopause. It is not a wall you can see, it is not a curtain you can touch. It is an invisible membrane where one influence yields to another, where the solar wind surrenders to the galaxy's greater sea. Inside, the sun rules. Its breath, its magnetism, its particles dominate. Beyond, the Milky Way takes over. Radiation from distant stars, plasma drifting between systems, cosmic rays accelerated by supernova. These belong to the outside. The heliopause is the skin of our star's dominion, the final threshold. On August 25, 2012, Voyager 1 crossed that threshold. It did not send an announcement. No message declared, "I have left the solar system." Instead, its instruments simply recorded a sudden drop in solar particles, an equally sharp surge in galactic cosmic rays. plasma den, city around the spacecraft spiked by a factor of 40. Magnetic fields bent into new alignments. The crossing was silent, almost anticlimactic, but the meaning was staggering. For the first time in history, a human-made object had left the sun's bubble and entered the galaxy beyond. Voyager 2 followed 6 years later, in November 2018, and though it crossed at a slightly different distance, the story was the same. A sudden, unmistakable transformation. Inside was the sun, outside was the galaxy. To imagine the heliopause, think of the boundary between two seas. One flows from the sun, the other from the galaxy. Where they meet, currents collide, layers form, and turbulence churns. The heliopause is not a sharp edge, but a region of exchange where particles mingle, slip across, and transform. It is an electromagnetic frontier. Magnetic fields carried outward by the sun wrap against those of the interstellar medium, pressing, twisting, sometimes merging. Charged particles stream across in fits and bursts. Cosmic rays, long suppressed by the solar wind, surge inward once the shield falters. This is why Voyager's data was so dramatic. Inside, solar particles dominated. Beyond, galactic particles reigned. The heliopause is the moment one kingdom ends and another begins. It is important to note, the heliopause is not the true edge of the solar system. Beyond it lies the Oort cloud, a sphere of comets that may extend hundreds of thousands of astronomical units, held loosely by the sun's gravity. Voyager has not reached that and may never. But the heliopause is the edge of the sun's influence by wind. It is the practical frontier, the place where the sun's protection fails. For any traveler, this is the crossing that matters most. Beyond it, you are exposed to the galaxy as it is, unshielded, raw. And here came the surprise. Voyager's detectors found that just beyond the heliopause, the plasma was far hotter than expected. Tens of thousands of degrees, not flames, not fire, but energy of motion, particles whipping about with staggering speed. This region became known poetically as the Wall of Fire. It is a paradox. The density is so low, you could fit less than a handful of particles into a cubic centimeter, emptier than the best vacuums on Earth. Yet those particles move so fast that by definition, their temperature soars to tens of thousands of Kelvin, hot but untouchable, a fire without flame. For Voyager, the Wall of Fire was not a threat. Its instruments were too sparse, its body too indifferent to heat transfer. But for us, back on Earth, it was a revelation. The frontier was not cold and empty. It was alive with energy, stranger and more complex than theory had dared imagine. The heliopause is not fixed. It expands and contracts with the sun's cycles. When solar activity is strong, the heliosphere swells, pushing the frontier outward. When the sun quiets, the heliosphere shrinks, drawing the boundary closer. This is why Voyager 1 and Voyager 2 crossed at different distances, 122 AU for Voyager 1, 119 AU for Voyager 2. The bubble itself had shifted, reshaped by the sun's mood swings. This variability matters. It means the heliopause is not a wall carved in stone, but a skin that breathes. At times it offers greater protection, at others less. For Earth, shielded far within, these fluctuations are subtle, but for a spacecraft at the edge, or for future explorers venturing beyond, they are critical. Think of standing on a beach. Behind you lies the land, familiar, sheltered. Before you stretches the ocean, vast, uncharted, dangerous. The heliopause is that shoreline. Voyager was the first to step into the waves, to leave the safety of the sand and taste the salt of the sea. This metaphor captures the awe of the crossing. For billions of years, everything in the solar system had been bound inside the sun's bubble. Voyager broke that monopoly. It carried our presence, however faint, into interstellar waters. And in doing so, it proved something profound. Our reach does not end with our star. We are not forever prisoners of a single bubble. Crossing the heliopause also revealed what we had lost. Inside the heliosphere, the solar wind shields us from the galaxy's worst radiation. Outside, that shield collapses. Cosmic rays, accelerated by distant cataclysms, surge freely. Voyager's detectors recorded the difference instantly. Radiation levels jumped, proof that interstellar space is harsher than the bubble we left behind. For humans, this is sobering. Any mission beyond the heliopause will require shielding far stronger than we use today. And yet there is a kind of freedom in that harshness. Beyond the heliopause, we are no longer bound by the sun's breath. We are part of the galaxy itself, exposed but also embraced. In purely physical terms, the heliopause is just a shift in particle density and magnetic field. But in symbolic terms, it is so much more. It is the first time humanity has crossed into interstellar space. No empire has claimed it, no map has marked it, no eye has seen it, and yet our probe touched it, crossed it, and told us what lay beyond. It is not a destination, it is a beginning. The heliopause is not the end of the solar system, it is the doorway to the galaxy. As Voyager drifted beyond the heliopause, its signal weakened further. Today, it takes more than 20 hours for its faint transmission to reach us. Each word of data is a ghost, a whisper, a reminder that we are still listening to a spacecraft launched before many of us were born. It carries no flag, no emblem of conquest. It carries only its instruments, its golden record, and its patient endurance. But in crossing the heliopause, it became more than a machine. It became our messenger, the first envoy of Earth to leave the sun's cocoon and join the galaxy at large. And yet the story does not end here. Beyond the heliopause lies not silence but mystery. That region of strange, unexpected heat, the so-called wall of fire, still defies complete understanding. What powers it? How does it change with time? And what does it reveal about the vast ocean of interstellar space waiting beyond? That is the riddle we now face. Beyond the heliopause, Voyager expected emptiness, a cold and quiet gulf where the galaxy's particles drifted thinly, where the solar wind no longer mattered. But what its instruments recorded was not cold, not quiet, not passive. It was heat. A region of plasma, so thin it bordered on nothingness, yet so energetic its temperature soared to tens of thousands of degrees. Not a fire of flames, there is no oxygen here, no flickering tongues of light, but a fire of motion. The few particles scattered in this space moved at velocities that defied imagination, their kinetic energy translating into heat that could only be described in extremes. Scientists called it the wall of fire. The very phrase invites contradiction. How can there be fire where nothing burns? How can there be heat in the emptiest place imaginable? The answer is hidden in the definition of temperature itself. On Earth, we think of heat as sensation, the warmth of a flame, the sear of sunlight, the comfort of a blanket. But in the language of physics, temperature is simply motion. It is the speed of particles, the restless energy with which they dart and collide. And so in the thin plasma outside the heliopause, though the density was almost zero, the particles that did exist raced so furiously that their temperature soared to tens of thousands of Kelvin. If you could somehow place a thermometer there, it would scream hot. But if you placed your hand there, you would feel nothing at all, because there are so few particles to transfer heat. It is a paradox of frontier physics, a fire you cannot feel, a blaze without fuel, a furnace that offers no warmth. Voyager's detectors were not built for poetry, they were built to measure, to count, to log, yet their readings forced scientists to borrow the language of metaphor. The plasma wave instrument on Voyager 1 confirmed electron densities higher than any seen within the heliosphere. Voyager 2, 6 years later, confirmed the same pattern. The interstellar medium just beyond the heliopause was unexpectedly hot, unexpectedly dense. The spacecraft had not entered emptiness, it had entered a fiery veil. This discovery reshaped our understanding of the solar system's boundary. The heliopause was not a quiet edge, but a turbulent frontier where the solar wind's collapse and the galaxy's pressure forged a region of intense, invisible heat. To understand why this wall forms, imagine two opposing storms. One is the solar wind, blowing outward from the sun for billions of kilometers. The other is the interstellar medium, the diffuse plasma drifting between stars, itself shaped by distant explosions and galactic tides. Where these storms meet, they do not blend peacefully. They clash. The solar wind slows and compresses. The interstellar plasma pushes back. In this collision, energy is transferred, particles are accelerated, and heat builds. The wall of fire is the scar left by this battle, a frontier zone where the sun's breath finally dies. It is not uniform. Voyager's readings showed fluctuations, suggesting that the wall shifts with solar cycles, with galactic currents, with conditions we are onless. I'm beginning to map. It is a dynamic boundary, alive with conflict. That Voyager could detect this at all is a testament to its endurance. Remember, this spacecraft was built with 1970s technology, meant for a planetary tour that should have ended decades ago. Its detectors were not designed for interstellar space, and yet they still whispered the truth across billions of kilometers. Each reading is faint, delayed by more than 20 hours of light time. Each data packet is a survivor, fragile and irreplaceable, and yet from these whispers we piece together the revelation of the Wall of Fire. It is humbling. A machine older than many of us, designed in an era of slide rules and typewriters, gave us the first glimpse of the sun's true edge. What does it mean to cross such a threshold? Inside the heliosphere, the sun protects us. Its wind deflects much of the galaxy's radiation, keeping cosmic rays at bay. But beyond the heliopause, beyond the Wall of Fire, there is no protection. Here, radiation surges freely. Here, the galaxy itself is raw and unfiltered. Voyager is the first to taste this environment, and what it tells us is that the transition is not gentle. It is marked by turbulence, heat, and radiation. The Wall of Fire is not a soft handoff from sun to galaxy. It is a clash, a violent mixing, a storm in slow motion. For humanity, this is more than science. It is foreshadowing. One day, when we send starships beyond the heliosphere, they too will cross this wall. They will feel the surge of radiation, the heat of the plasma, the turbulence of colliding fields. Voyager has given us the first warning. And yet, for all its drama, the Wall of Fire is not vast. Voyager crossed it quickly, in astronomical terms, a span of a few astronomical units, a tiny fraction compared to the heliosphere as a whole. It is a thin skin, a membrane stretched across the solar system's frontier. But within that thin skin lies the essence of transition. It's the place where inside becomes outside, where the sun's story ends and the galaxy's begins. It is the solar system's horizon, the line that separates familiar shelter from cosmic wilderness. And in that horizon burns a fire no eye can see. Why do we call it fire? Why use a metaphor that risks misleading? Because the human imagination needs thresholds. We understand walls, flames, borders. To say plasma at tens of thousands of Kelvin is true but sterile. To say a wall of fire captures the drama, the awe, the danger. It is not literal. It is not a blaze that could ignite wood or melt steel, but it is real. It is the heat of cosmic collision, the fire of particles in motion, the energy of a frontier alive with struggle. And for us, back on Earth, this metaphor matters, because it reminds us that the frontier is not dull, it is not quiet, it is alive, burning in silence, waiting for those brave enough to cross. The wall is not constant. Voyager's measurements revealed that its properties shift with time. As the solar cycle waxes and wanes, as solar storms ripple outward, the heliopause and its fiery veil expand and contract. The fire brightens and dims, flares and fades. This means the Wall of Fire is not a static structure, but a breathing phenomenon. It is tied to the sun's heartbeat, shaped by rhythms that began long before life on Earth and will continue long after. Imagine it. A frontier that pulses, alive with the star that sustains us. Voyager crossed at one moment in this cycle. If we could send another probe tomorrow, or in 100 years, it would find a different wall, a different fire, shaped by a different solar rhythm. Beyond the Wall of Fire lies true interstellar space, a realm Voyager is only beginning to explore. Here the plasma is cooler but denser. Here cosmic rays flow freely, carrying the history of distant explosions. Here the sun is no longer dominant. It is just another star, its influence lost in the ocean of the galaxy. But before Voyager could drift into that realm, it had to endure the fiery veil. And in doing so, it showed us that the edge of the solar system is not quiet but dramatic, not smooth but turbulent. The Wall of Fire is the solar system's scar, the mark of its collision with the galaxy. Perhaps the Wall of Fire is more than physics. Perhaps it is also a metaphor. Every frontier, whether cosmic or human, is marked by struggle. To leave the familiar always requires passing through turbulence, through heat, through danger. The Wall of Fire is our solar system's reminder that growth is not gentle, transition burns. Voyager endured it, and so may we, one day when we follow its path with ships of our own. But Voyager was not alone in sensing this frontier. Far behind it, another spacecraft, New Horizons, looked outward and detected a faint glow of hydrogen, another sign that the edge of our bubble is alive, glowing, burning in silence. What is this hydrogen wall? How does it connect to the fiery veil Voyager crossed? And what does it tell us about the complex, layered structure of our solar system's boundary? That is the story we now turn to. Far behind Voyager, another traveller was still racing outward, smaller, younger, faster. Its name was New Horizons. Launched in 2006, it carried humanity's first close-up dreams of Pluto. In 2015, it flew past that icy world, revealing a heart-shaped plain of nitrogen ice, mountains of frozen water, and a sky tinted with hazy blue. For most of the world, New Horizons became famous for that flyby, for turning a distant T into a living world. But after Pluto, New Horizons kept going. It pressed deeper into the Kuiper Belt, past ancient frozen remnants of the early solar system, and as it drifted farther, it turned its sensitive ultraviolet instruments toward the edge of the sky. There it saw something faint, something unexpected, a glow of hydrogen. The glow was not visible light, it was ultraviolet, invisible to human eyes, but detectable to New Horizons instruments. It came from interstellar hydrogen atoms just outside the heliosphere, lit up faintly by the collision of solar wind and galactic medium. This faint emission was not new. Decades earlier, Voyager and even Pioneer spacecraft had hinted at it, but New Horizons confirmed it with clarity. The glow seemed to outline a boundary, a hydrogen wall, pressed against the outer skin of the heliosphere. It was as though the sun's bubble, invisible in itself, had been outlined in faint, ghostly light, a halo of hydrogen glowing at the edge of everything. Why would hydrogen glow here, at the frontier of the solar system? The answer lies in the collisions between solar wind particles and interstellar hydrogen atoms. When the two interact, they create excess ultraviolet emission, a kind of cosmic backlight. The result is a faint but measurable glow, a signature of the frontier. This hydrogen wall is not a solid barrier. It is a region of compressed interstellar hydrogen, piled up where the heliosphere presses outward. Think of snow drifting against the windshield of a car, piling into a ridge as the vehicle plows forward. The solar system itself is moving through the galaxy at about 828,000 kilometers per hour. And at its nose, hydrogen gathers, glowing faintly, marking the struggle between our star's breath and the galaxy's wind. The hydrogen wall is different from the fiery plasma Voyager detected, yet the two are related. Both are products of collision and compression at the heliosphere's edge. The plasma burns hot because particles are accelerated. The hydrogen glows because atoms are compressed and excited. Together, they show us that the boundary is not simple. It is layered, textured, alive. A region of both fire and glow, heat and light, turbulence and stillness. Voyager gave us one piece of the picture, New Horizons another. Neither alone is complete, but together they sketch a frontier far stranger than we ever imagined. The hydrogen glow was not the only mystery. Around the same time, another mission, IBEX, the Interstellar Boundary Explorer, was mapping the sky in energetic neutral atoms. To its astonishment, it revealed a glowing ribbon stretching across space, aligned with the edge of the heliosphere. Scientists debated what it meant. Was it magnetic draping of the galaxy's fields around our bubble? Was it charge exchange interactions at the boundary? No answer was complete, but the IBEX ribbon, the Voyager plasma, and the New Horizons glow all pointed to the same truth. The sun's edge is not smooth. It is structured, dynamic, riddled with phenomena we are only beginning to grasp. For future explorers, the hydrogen glow is more than a curiosity. It is a beacon. Unlike the plasma wall, which can only be measured up close, the hydrogen glow can be detected from afar. It is visible, faintly, even from Earth's orbit, given the right instruments. This means we can study the heliosphere's shape without sending a spacecraft to its edge. We can watch how the glow changes over time, how it shifts with the sun's cycles, how it flares during storms. The hydrogen glow is a tracer, a map, a living sketch of the frontier. Like the heliopause itself, the hydrogen wall is not fixed. New Horizons data showed it varies with solar activity, swelling outward when the sun is strong, contracting inward when the sun quiets. In this way, the glow breathes with the sun's heartbeat, a distant echo of rhythms that drive space weather here on Earth. This breathing is slow, measured in years and decades, but it reminds us that even at the edge of the solar system, the sun's pulse is felt. Its influence does not vanish abruptly. It fades, it shifts, it leaves echoes in hydrogen and plasma, light and fire. For scientists, the hydrogen glow is data. For humanity, it is something more. It is a reminder that we live in a bubble of protection, outlined by light we cannot see. We are cradled inside a faint halo, drifting through the galaxy like a ship through an ocean. The glow is the bow wave of our voyage, marking our passage, announcing our presence. It is humbling, it is beautiful, it is a reminder that the sun is not isolated but in dialogue with the galaxy around it. There is something poetic in the way these spacecraft complement each other. Voyager, launched in the 1970s, battered and aged, felt the plasma fire up close. New Horizons, sleek and modern, launched in the 2000s, looked outward and saw the glow from afar. Together they give us a stereoscopic view, the near and the far, the inside and the outside, the touch and the sight. It is as though one hand reached out to feel the wall, while another eye looked across the horizon to see its outline. Both are telling the same story from different angles. Why does this matter? Because the hydrogen glow, like the wall of fire, reveals that the frontier is not passive. It is a site of struggle, of compression, of interaction. It tells us that our star is not isolated but engaged, colliding with the galaxy's medium in real time. And it reminds us that when we one day venture outward, when we build ships to sail beyond the sun's shield, we will not cross a gentle threshold. We will pass through fire and glow, turbulence and radiation, a frontier alive with energy. The hydrogen wall is not an obstacle, it is a message. It tells us you are leaving home. But the story does not end with Voyager and New Horizons. From Earth itself, IBEX and its successor missions have mapped strange ribbons of energy at the frontier, hinting at forces even more mysterious. Magnetic scaffolds, cosmic alignments, scars written across the heliosphere. What are these ribbons? Why do they appear where they do? And what do they reveal about the sun's hidden battle with the galaxy? Long before Voyager crossed the heliopause, long before New Horizons glimpsed the hydrogen glow, another mission turned its eyes outward, not from the edge of the solar system, but from Earth itself. Its name was IBEX, the Interstellar Boundary Explorer. Launched in 2008, IBEX had a deceptively modest goal: to map the frontier of the heliosphere, not with cameras, but with particles. It orbited Earth, looking not outward with light, but inward with signals carried by the very atoms escaping the sun's domain. And what it revealed stunned scientists. Across the sky, IBEX found a mysterious ribbon of energy, a band of brightness that wrapped the heavens like a ghostly scar. No one had predicted it, no theory had explained it, and yet there it was, etched across the cosmic horizon, aligned with the very edge of our bubble. To understand the ribbon, you must first understand how IBEX sees. The frontier of the heliosphere is not something visible to the naked eye. But when charged particles from the solar wind collide with atoms of the interstellar medium, they can swap charges, creating energetic neutral atoms, particles that are no longer trapped by magnetic fields. These atoms travel in straight lines back toward the inner solar system, carrying with them the imprint of where they were born. IBEX was designed to catch these messengers. It is a particle observatory, detecting the invisible spray of energetic neutral atoms that flow inward from the heliopause. By mapping their directions and energies, it paints a portrait of the frontier, and in that portrait the ribbon appeared. Imagine a glowing band stretching across the sky, brighter than anything else in IBEX's maps. Not a smooth sphere, not a random scatter, but a distinct arc, as though the boundary of the heliosphere had been traced by some unseen hand. The ribbon was narrow but long, extending across much of the sky. Its brightness was unexpected, 10 times higher than surrounding regions, and its position seemed to align not with the sun itself, but with the direction of the local galactic magnetic field. For scientists, this was a revelation. The heliosphere was not merely a bubble inflated by the solar wind. It was shaped, perhaps even constrained, by the larger forces of the galaxy. One explanation emerged: magnetic draping. The Milky Way is filled with magnetic fields, stretched and twisted by the motions of stars, supernovae, and galactic currents. As the sun plows through the galaxy, these magnetic fields wrap around the heliosphere like threads around a balloon. The ribbon may be the place where these fields press hardest, guiding the flow of particles and creating a region of enhanced emission. In other words, the glow is not random, it is a signature of the galaxy's grip on our star's bubble. If this is true, the ribbon is more than a curiosity. It is a message. The heliosphere is not independent. It is sculpted, bent, shaped by the galaxy itself. But magnetic draping is not the only explanation. Some scientists suggest the ribbon may result from charge exchange processes, where solar wind ions interact with neutral atoms in complex ways. Others propose it could be the result of turbulence in the heliosheath or a resonance effect between the solar wind and galactic fields. The truth is, no single model explains everything. The ribbon remains partly a mystery, but in science, mystery is fuel. Each possibility expands our view of the heliosphere, reminding us that we are only beginning to understand how stars live inside galaxies. Whatever its origin, the ribbon is haunting. It is like a scar across the night sky, a reminder that boundaries are never smooth. The heliosphere is not a perfect bubble, but a complex frontier, marked by turbulence, heat, glow, and now ribbon. It is almost poetic. Voyager felt the fire, New Horizons saw the glow, and Ibex traced the scar. Each spacecraft added a layer, each revealing the frontier not as a simple edge but as a tapestry of phenomena. The ribbon is the most mysterious of these, an imprint of forces larger than the sun itself. Some scientists have suggested the ribbon could serve as a kind of compass, pointing us toward the direction of the local galactic magnetic field. If true, it tells us not only about our bubble, but about the galaxy's architecture, about the invisible lines of force that stretch for light years. This means Ibex is not just mapping the heliosphere, it is probing the galaxy's skeleton, the scaffolding of magnetism that threads between stars. To see the ribbon is to glimpse the unseen framework of the cosmos. When the discovery was announced in 2009, scientists were stunned. "We had no idea this ribbon existed," said one. "It's as if we painted the sky and a bright stripe appeared where we weren't even looking." For the public, the ribbon was harder to grasp. It had no photograph, no image of flame or glow, only a particle map. But for those who understood, it was profound. It showed that the sun's frontier is not isolated. It is entangled with the galaxy in ways we are only beginning to sense. It is a reminder we are not alone. Our star, our system, our bubble, all are threads in a larger web, tugged and bent by forces far beyond our control. The story of the ribbon is not finished. In 2025, NASA will launch IMAP, the Interstellar Mapping and Acceleration Probe. IMAP will carry instruments even more sensitive than IBEX, mapping the iosphere's frontier in unprecedented detail. It may explain the ribbon, it may reveal new structures, it may show us how cosmic rays are accelerated at the boundary, how turbulence shapes the frontier, how the galaxy's fields weave through our sun's bubble. Voyager gave us touch, New Horizons gave us sight, Ibex gave us scars, IMAP will give us clarity. But beyond the data, the ribbon is a symbol. It reminds us that the universe is stitched with lines we cannot see. Magnetic fields, invisible but powerful, shape the destiny of stars and planets. The ribbon is the first thread we have traced across the galactic loom. To study it is not just to understand the heliosphere, it is to glimpse the larger fabric we are woven into. And so as Ibex traced this scar across the sky, another truth emerged. Our heliosphere is not still. It drifts through the galaxy at hundreds of kilometers per second. Ahead lies not emptiness, but motion, collision, and change. The solar system itself is moving, carrying Earth and all its worlds into an uncertain future. At the edge of everything we knew, Voyager crossed into silence, beyond the sun's breath, beyond the warmth of its protection, beyond the cradle of the heliosphere. It drifted into the galaxy itself. It is still there, still moving, still whispering faint signals back to Earth. But one day, even that whisper will fade. The nuclear heart that powers Voyager will grow cold. Its instruments will fall silent. Its antenna will no longer turn toward home. And then it will become what it was always meant to be, a message in a bottle, cast into the cosmic ocean, adrift for eternity. But its silence will not mean its story is over. Voyager's journey is more than a line on a map. It is a statement. For billions of years, everything in the solar system had been contained within the sun's invisible bubble. Planets, moons, comets, asteroids, all of them were children of the heliosphere, sheltered inside its shield. Voyager broke that monopoly. It crossed into interstellar space, proving that the sun's kingdom has a border, and that border can be passed. In doing so, it reminded us of something profound. Boundaries exist to be crossed. At the edge, we discovered fire that does not burn, glow that cannot be seen, ribbons traced by forces larger than stars. We discovered that the sun is not sovereign, but a participant in a larger struggle, its breath colliding with the galaxy's wind, its bubble sculpted by magnetic fields that stretch for light years. The heliosphere is not an isolated shield, it is a dialogue, sun and galaxy in constant negotiation. And we are passengers within that dialogue, carried along as our star sails through the Milky Way. The edge of the solar system is not a clean line. It is a turbulent frontier, alive with fire, glow, scars, and whispers, a place of transition where the familiar yields to the unknown. For scientists, Voyager's data is a treasure, play, estimate densities, particle counts, magnetic shifts. But for humanity, the meaning runs deeper. Voyager is not just a machine, it is a mirror. It shows us that our home is finite, that the sun's protection, though vast, has an end, that beyond it lies a universe unshielded, raw, alive. And it shows us that we are capable of leaving, not just in imagination, but in reality. When the first humans step beyond the heliosphere, they will follow Voyager's trail. They will cross the wall of fire, see the hydrogen glow, trace the ribbon in the dark. They will feel in their bones what Voyager measured with instruments, that leaving home is not easy, that transition is turbulent, that freedom is bought with struggle. But Voyager carried more than instruments. It carried a message, the golden record. A disc of copper and gold engraved with music, greetings, sounds of earth, the laughter of children, the heartbeat of a mother. It is a time capsule of our world, drifting now beyond the sun's reach. One day, perhaps millions of years from now, another civilization may find it. They may play its sounds and hear our voices. They may know that once, in a small system orbiting an ordinary star, there was life that looked outward, wondered, and dared to send a message into the dark. Voyager is not just science, it is us. Think of what this means. For the first time, humanity has become interstellar, not in person, not with starships, but with emissaries. We have crossed the sun's frontier. We are no longer confined to our bubble. This changes our perspective. The Earth is not the center, the sun is not infinite. Our home is fragile, temporary, finite. Beyond it lies the galaxy, vast and indifferent, and yet that vastness is not hostile, it is inviting. The wall of fire is not a warning to stay in, it is an invitation to step out. Voyager will keep drifting long after we are gone, long after Earth has changed, long after the sun has burned through its fuel, long after our species has either perished or moved on. In 40,000 years, Voyager will pass within 2 light years of another star. In 300,000 years, it will drift deeper into the Milky Way. In billions of years, it may wander between galaxies. It will not stop. It will not turn back. It will be eternal, carrying our message through space and time. And in that eternal drift lies a whisper that we too are meant to keep moving. The frontier is never comfortable. It is never smooth. It is always turbulent, always uncertain, always burning. But that is where growth happens. That is where we learn who we are. The wall of fire teaches us that transition is not gentle. The hydrogen glow teaches us that even the thinnest veil can shine. The ribbon teaches us that unseen forces shape us. The heliosphere teaches us that protection has limits. And Voyager teaches us that courage is not about knowing what lies beyond, it is about going anyway. What makes this story extraordinary is not the spacecraft itself, but the people who built it, who guided it, who still listen to its fading voice. Generations of scientists, engineers, and dreamers, many long gone, are stitched into Voyager's journey. Their fingerprints are on its circuits, their voices on its record, their curiosity in its trajectory. Voyager is proof that we are more than survival machines. We are explorers, storytellers, meaning makers. We send pieces of ourselves into the dark because we cannot help it. It is what we are. When Voyager's signal finally dies, when the last bit of data flickers into silence, there will be sadness. But there will also be wonder, because silence does not mean the end. Silence means the baton has been passed. Voyager will continue carrying our message farther than we will ever go. And perhaps that is the point. Perhaps the lesson of the frontier is not that we must conquer it, but that we must accept our place within it, small, fragile, but unafraid. In the whispers of Voyager's journey, we hear our own reflection, that we too are finite yet eternal, fragile yet courageous, sheltered yet restless, that the universe is not empty, but alive with fire, glow, ribbons, and motion, and that beyond every boundary lies not an end, but a beginning. The edge of the solar system is not the edge of us, it is the edge of what we knew. Voyager crossed it, and in doing so proved that knowledge itself has no wall. The wall of fire, the hydrogen glow, the ribbon in the dark, these are not barriers, they are invitations. Invitations to imagine, to explore, to keep going. And as long as Voyager drifts, so too does our story. Into the galaxy, into eternity, into the infinite dark, where our whispers will never be lost,